Hi everyone, I'm Sherry, fourth-year PhD student at University of Washington. Today I'm going to talk about Tempura, query analysis with structural templates. This is the work I did during my internship at Apple. We expect modern search engines and intelligent agents to answer questions. Many of these tools are pretty good now, but these systems still fail at times. In a recent paper, when a user asks the same question to an agent within a day, the agent gives him different answers. To improve performance, developers still need to analyze the query data to understand what type of queries users ask, where the models work well, and where they can be improved. We want to perform these analyses on groups of similar queries so that they are more generalizable than individual queries. But the grouping is hard. If you have structured data, you can say, let's do a group by and call it a day. But for text data, you usually don't have a good specific feature or column to slice on and have to rely on more fuzzy methods like clustering or topic modeling. These methods are not so interpretable or actionable. Consider these three queries. How can I learn English? How can I learn Python? How can I install Python? They will all be clustered together because the algorithm cannot distinguish that they are similar in different ways. It's difficult for the developers to predict what queries are included and what are not, and it's even more difficult to figure out ways to fix the clusters. But if you look closer, compared to some other form of text data like an article, query text are shorter, more compact, and usually have some interesting structures that we can use for grouping. Like here, these three questions all have the same question word, have some verbs, and are about some language or programming language. We take advantage of these structures and propose to group query data with structural templates. Structural templates abstract queries by replacing certain tokens with their linguistic features, so the queries with shared templates can be grouped and examined together from different angles. For example, you can replace Python with its named entity, PL, so we can find programming languages that users care about when asking how can I learn questions. Or we can also gather queries on Python if we abstract learn to its part-of-speech tag verb. Structural templates also help us examine queries at different granularities. How can I learn Python here could only just cover one exact query. How can I learn PL can only cover programming languages. And how can I learn none will also cover natural language and even more general non-language queries like how can I learn physics. These templates are useful for various analysis tasks. For example, we could represent our dataset with the templates and recognize that maybe how can I learn language is a very common question pattern. Or we can also analyze our model with the templates and answer questions like, my model is wrong on how can I learn Python. Is it because it cannot answer questions about how to learn programming language, or because it cannot recognize Python? We integrate all the nice properties of structural templates in one interactive user interface called Tempura. Tempura summarizes a dataset distribution with overview templates, provides access to raw queries, and supports in-depth navigation among related templates. Now, let's walk through Tempura with a specific case. The case is from our user study with several NLP developers at Apple. We want to use Tempura to better understand the performance of a query classifier. Our task here is to predict if a query is in one of the four categories: food, health, procedural explanations on how to perform some tasks, or none of the above. As a starting point, we provide a set of the templates to summarize the query distribution. Each template has some attributes associated with it, so users can sort or filter on them to answer various data or model-related questions. The attribute starts with coverage, or the number of queries covered by a template. Then, there are several attributes relevant to the modeling task. For our classification task, we have the error rate, or the ratio of incorrectly predicted queries, the distribution of the ground truth label, and the prediction distribution, so we can see if the model would overfit to a syntax structure. The templates can be cross-filtered with the raw queries so that we can either get an overview from the template statistics and then find corresponding queries, or start with a particularly interesting query and generalize to a larger template group. For example, here, to find templates that's difficult for the model, let's sort by the error rate in the template overview. The template with the highest error rate is how can pronoun verb noun, with 26 covered queries. 46% of them are incorrectly predicted. Inspecting the covered queries, we find some noisy labels. Here, similar queries like how can I cook salmon and how can I boil eggs are labeled differently as procedural or food. This makes sense, as queries on cooking procedures can make these two label pairs non-exclusive. With this supporting evidence, we might switch to a multi-label classifier. Now, because all the query tokens can be changed to different linguistic features, the number of templates for a dataset is usually large. To effectively summarize query distribution, we only select a subset as the overview. The details of the algorithm is in the paper, but intuitively, we consider two aspects. To construct representative groups of queries, we prioritize templates with high coverage. At the same time, to effectively initiate analysts exploration, we want to include templates that are more preferred than any of its neighbors. What do we mean by preferred? Like we mentioned before, templates have different granularities and can move or traverse between them. Let's again use how can pronoun verb noun as an example. We can traverse down and make the template finer grained if we split the noun token to the actual nouns. This will give us many child templates, each asking how to deal with some random stuff. How can I or you verb emails, chats, eggs? On the other hand, we can also traverse up. Here, by replacing how with its abstract part-of-speech tag adverb, we can get to a sparser parent template, and it would express more general questions by merging other question words like where can I do something or when can I do something. Through traversal, some of the resulting templates are more informative to explore than others. We prefer templates that all of its traversal are not informative or less likely to yield more interesting exploration. This way, templates that are interesting can be in the overview from the beginning without the need for additional interactions. If we plot the query coverage distribution of each template group, we will see that splitting down might not be interesting, because there is a large number of sparse and unrepresentative stuff, and the resulting children groups will be too small. We can color the traversal arrow to indicate how informative it is. Merging how to adverb is also not informative. The sibling groups where and when only have a small number of queries. As a result, the merged group will still mostly contain questions starting with how, but with a meaninglessly vague question word adverb. But traversing up at can might be relatively more interesting. With both do and can having many queries, abstracting can to verb gives us a significant gain of queries to view together. Still, because should and would are long tails, our selection would recommend analyzing do and can as two separate groups initially. For other templates, analysts can access them through interactive traversal, so these templates can provide additional views of the data on demand. Back to our case, we traverse up the relatively more informative can to how verb pronoun verb noun. We then see three other sibling templates here triggered in the neighboring template table with verb tokens do, should, and would. We would imagine questions asked in the form of how can, how would, how should, etc. to be quite similar. But in fact, when we preview the covered queries, do seem to cover more food-related queries. Let's verify this with label distributions. Indeed, in how can pronoun verb noun, Queries are labeled as house, noun, and procedural, whereas those in how-do pronoun verb noun are mostly food-related. This is an unexpected label distribution difference, but we can easily fix it with data augmentation. For example, we can create another batch of food questions by replacing their do with can. Despite the distributional gap, these templates still seem semantically identical, and we can merge them to inspect how verb pronoun verb noun. Let's instead traverse down the second verb to understand what are the actions being queried. Among the 4 child templates covering most queries, how verb pronoun cook noun has the most indicative verb with all queries labeled and predicted to be food-related. How verb pronoun do noun has high error rate with only one predicted label noun, but almost all its queries are labeled as procedural. Looks like the model interface to this form of template pattern. Make has the highest coverage, and the model predicts most of the make queries to be food. However, 6 of 34 queries are labeled as procedural. If we look into the queries, again, the model is not strictly wrong, because many queries are food-related and could have both labels. Finally, we also see a modal error outlier in how verb pronoun play noun. With chess and oatmate both being board games, how do you play oatmate is labeled as noun but predicted as procedural, whereas chess shows the reverse. This means we should double-check the label as well as the modal stability on various similar nouns. Our users made many more pretty interesting observations on the distribution of query datasets, labeling errors, and modal error patterns and outliers. Our highlight from this is, you can see half of the errors our developers found were dataset related. It shows the importance of data quality validation and data wrangling before any modeling. Our user also commented that Tempura provided finer grained analysis, intuitive starting points, and made their process more effective. Extending beyond analyzing just one dataset, we compare multiple datasets to see if our structural templates can help reveal dataset characteristics. We did it on 3 datasets. MS Marco and NQ are public search queries from Bing and Google search engine, and Assistant is from our internal anonymized search queries. For each dataset, we sampled 10K queries, extracted and selected overview templates from them, and finally compared the template distribution. Here I will just highlight the result from Assistant and MS Marco. The high-level takeaway is queries from different sources differ. Even though would be noun is an important template in both Assistant and MS Marco, this template has a much higher coverage in the MS Marco. The selected templates diverge afterwards. MS Marco has many just noun queries, while Assistant has more what do noun mean queries. This noun case is actually pretty interesting. All the query datasets have a filtering step, and the goal is to keep knowledge-seeking question queries. But only MS Marco shows noun queries. Just from this one template, it's clear the dataset filtering strategies are different, and this is not something you can observe from the question word distribution. Tempura introduces the concept of structural templates, summarizes a query dataset by selecting a representative subset of templates, and also helps analysts navigate the template space interactively. Our user study shows that Tempura can support data exploration and modal error analysis. Our case study shows that Tempura can expose distributional differences between datasets. Overall, dataset quality and distribution matters a lot, and we encourage future explorations on data understanding and wrangling. We imagine Tempura, or essentially the structural template exploration approach, to be useful in many more ways. First, developers can mitigate the distribution difference through data augmentation. To flag potential inconsistent labels, the dataset requester can use the templates to provide a global perspective in the data labeling process. The system can easily compare a newly labeled query to its structurally similar previously labeled queries and warn the labeler if the labels do not match. Also, quality analysts and designers can build template-based diagnostic sets to address model biases. Thanks for listening.